Now, if I ask you to find the limit as x approaches 2, and I put a minus on it, like this, of that function, what does that mean?
It means it's approaching from the left. Yes.
What is it?
From the left.
Yes. It means really tell me find, the question has really become find the y value as x approaches 2 from the left. When you get close to 2, you go, well, let me get close to 2. Right there. What is the y value of that function there? What is that equal to? 1. Right? We'll say it's 1. Now, if I ask you what's the limit as x approaches 2 plus of that function, this one means find the limit, the y value, as x approaches 2 from the right. I don't have room to write the right. I'll go 2 from right. So as you approach the 2 from the right, you're right here. What is the y value equal to? I'm exaggerating, making. That looks like a 2. I put the line farther. Usually it would be closer to that. So the y value is going toward the 2. Now we'll learn quickly, it just happens to be in this example, if the limit from the left side of any number does not equal the limit from the right side, then the limit does not exist. As x approaches a, we go DNE, does not exist. So the limit have to be there and the numbers have to be the same for it to exist. If the limit from the left equals the limit from the right, yes, you have a limit and the value is that number. But if they're not equal to each other, the limit does not exist. So in this example, my limit does not exist because 1 does not equal to 2. When I say the limit as x approaches 2. So again, if the question was, what's the limit as x approaches 2 for this problem of that function, I have to write DNE. There is a limit as x approaches 1. There is a limit as x approaches 0. There is a limit as x approaches 3, but not as x approaches 2, because the two numbers don't match each other. The two numbers have to be the same for the limit to exist. I'm just going to take different pictures and ask for the limit for them. Let me put some crazy problem there, picture. I'll give you a chance to finish writing. I'll start with one not so crazy. Let's say we are given this problem. F of x equals x squared plus 3 when x does not equal to 1 and is equal to 1 when x equals to 1. Yep. It's a piecewise function. X squared plus 3, we know that's a parabola. Shifted up how many units? 3 units. So a parabola looks like this. The only difference here is what? When x equals to 1 right here, I have a hole. So let me put a hole in it right there. I'm making the hole bigger, but normally much smaller than that. It's a single point. When x equals 1, it says the value is 1. So this is what my function looks like. This is the 1. And if you plug it into this one, what's 1 squared plus 3?
Oh, 1 squared plus, it's 3.
It's 4, right? So if you were to look at the y value right there, that's a 4. But there's a hole there. So if I ask you what's the limit of that function as x approaches 1 from the left side? So you find where the 1 is and you look at the number before the 1. What is the y value right before 1? This is the 1. Right before that, so when you round that, that's what? You go 3.999999999. What is that? 4. And what's the limit as x approaches 1 from the right side? Again, let's find out. That's right after the 1. So this is the 1. Let's go right after the 1. And that value there is what? I had to push it to the right because that dot was in the way there. Yep. 4.00000001. So we'll make that value what? 4. Are these numbers the same? So if we ask you what's the limit as x approaches 1 of that function, what's the answer? 4. Even if the function has a hole, we're not saying what's the y value when x is 4. We're saying as you get close to the 4 from the left side, what is the y value? As you get close to 4 from the right side, what's the y value? That's a 4. The fact that two numbers are the same, then the limit exists, and that's your answer. Let me try another function. I'll draw a picture of it. It's going to be a little bit longer. This problem has a few pictures in it. We'll go through them. This is the negative 2 here. Negative 1, negative 2. For negative 2, the function looks like this. Then, for here, it looks like this. That's the 1. The value is 1 at 0. Has a hole in it. At 1, 2, we have a hole at 2 here. And let's say the value looks like this. Five there on the top. And negative 1, 2, 3, 4. That's a picture like this. This is the negative 2. This is the 0. This is the 2. That's the 4. And let's go through that now, ask multiple questions. I'll give you a chance to draw that picture. So for this homework assignment, when you get to, you're going to be looking at pictures like these, and we're going to be asking you, what's the limit, like this. What's the limit as x approaches -2 minus? That means from the left. So what is the y value there? -2 from the left. Let's take a look at it. This is the -2 from the left. The function's not going to cross on the top. It's going to cross where? On the bottom. Where is it going to go to? At -infinity. That's where it touches it. What's the limit as x approaches -2 from the right? Positive infinity. Notice where it touches it. From the right side, there's no function on the bottom. It has to be on the top. So it touches right up there. Plus infinity. So if we ask you from the left, you write -infinity. If we ask you from the right, you write what? Positive infinity. If we ask you what's the limit of f of x as x approaches -2, we're not saying left or right. What's your answer? Does not exist. Very good. The left side, the right sides don't match. Now let's look at the 0. What's the limit of the same function as x approaches 0 from the left side? What is it? 1. Notice as you approach 0 from the left side, what's the y value? Right there. It looks like 1. What's the limit of that function as x approaches 0 from the right side? There's the 0 from the right. I'm going to exaggerate because there's a big hole in the way. Let me move it to the right now. What is it equal to? 5. It's touching it right at the 5. I'm just putting the line far away because that big hole in the way. But you move closer to it, it looks like right next to the y-axis. When you touch it right there, it's 5. So what's the limit of this function as x approaches 0? That also does not exist. Let's look at the 2 and the 4. What's the limit of this function as x approaches 2 from the left? What is the y value? Zero, yes. It's right there. The height is 0. And what is it from the right? From the right will be what?
0.
Also 0. Right there. That's the height. So what's the limit of this function as x approaches 2 then? That's 0 because the numbers are matching. If they don't match, there is no limit. If they match, that's your answer. And the last one, we'll do the 4. What's the limit of f of x as x approaches 4 from the left? So what is the y value as you get close to 4 from the left side? Where's y? So here's 4 from the left side, and the y value is going up, 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 up. Where's it going to touch the graph at? Plus infinity. Now, when you approach the 4 from the right side, what is that equal to? From the right side again, right after the 4, where are we going to touch the graph? At also positive infinity, way up there. Are these two the same? Yes, so the limit as x approaches 4 of that function is equal to infinity. Don't write does not exist. Go, well, you can't reach infinity, but you still write infinity. There's a limit, they're both going to infinity. Does not exist means one going this way, one going different value. That's what does not exist. And that's how you're going to find the limit graphically. The problem is, a lot of times you're not going to be given the picture. You're going to be given an expression and says find the limit. So I'll give you an expression, we'll say let's find the limit. I can probably combine the videos together. What do you think? Should I end it instead of the other one? Make them separate?
How long is this one?
I don't know. It's not that. You know what? I'll stop it.